Notice that the relation described by the table is a function, where the constant difference between consecutive entries in the first row is 1, C1, while the constant between the second row is 2. The table describes a linear function defined by the equation y equals 2x minus 2, where y is the number of unshaded circles and its x is the number of shaded circles.
And that was sci-hi for some simple examples of linear functions. And now I am to graph a linear function. Draw the graph of x minus y plus 3 is equal to 0. Let us find the x-intercept and y-intercept of the graph. For the x-intercept, when y is equal to 0, x is equal to negative 3. Thus, negative 3, 0 is a point on the graph of x minus y plus 3 equals 0. So, for the y-intercept, when x is equal to 0 and y is equal to y is equal to 3. Therefore, the point 0, 3 is a point on the graph of x minus y plus 3 is equal to 0. So, in plotting the point, we have this graph. Yay! The end.
So that was Nicole talking about how to graph linear functions. So I am now here to talk about how to look for the equation of a line. So based on Nicole's example, we have an equation y minus y sub 2 is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1 multiplied by x minus x sub 2. So this is the formula or the equation that we are to use in order to get the equation of a line. So we are just to substitute. So we have here the values. Y sub 1 is equal to 0, y sub 2 is equal to 3, x sub 1 is equal to 3, and x sub 2 is equal to 0. So we have here, if we substitute, we have y minus 3 is equal to 3 minus 0 over 0 minus 3 multiplied by x minus 0. So to simplify everything, we get y minus 3 is equal to x. So if we are to add positive 3 to both sides in order to cancel negative 3 in the y side, so we get x minus y plus 3 is equal to 0.
Before we forget, here's the formula for slope. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Today, our topic is about parallel lines and perpendicular lines. Here's an example of a parallel line. We cannot distinguish their slope, so we have to convert it to slope-intercept form and observe its slope. And here's an example of perpendicular line. Still, we cannot distinguish its slope, so we have to convert it into slope-intercept form and observe its slope. We can know it because it has different signs. In parallel lines, they have same slope, while in perpendicular lines, they have opposite slope.
Now, thanks to my other group mates, I'm pretty sure you've learned a lot, haven't you?
Yes.
But wow, since we didn't tackle most of the slopes, I am here, back, to tell you more about slopes. Here are the slopes. Here is the positive slope. Notice that I am going upward as I walk. And here is the negative slope. Notice also that I am going down as I walk.